Lesson 5.4, Solving Radical Equations and Inequalities. Our essential question, how do you solve equations containing radicals and rational exponents? There are 2 problems left on the page for independent practice. Let's take a closer look at those. So I have a parenthesis raised to the 3rd fourth power. My job is to ask myself, what am I going to raise this expression by? So when I multiplied these 2 exponents together, they would give me a 1. It would be the reciprocal. So if this is 3/4, we're going to raise it to the 4/3 power. If the left side gets raised to the 4/3, the right side is going to get raised to the 4/3. 3/4 times 4/3 is 1, so those exponents 1 each other out. We have x plus 2 equaling, this is the 3rd root of 8, all raised to the 4th power. So I have x plus 2 equaling, the 3rd root of 8 is 2. So I have x plus 2 equaling 2 to the 4th power is 16. I'm going to solve for x. I get x to equal 14. Now our job is to now figure out, is this an extraneous solution? And you check that by plugging in your answer to the original typed in problem. So instead of x, we are going to write the number 14. So we have 16 to the 3/4 power equaling 8. This is the 4th root of 16, all raised to the 3rd power. The 4th root of 16 is 2. So this is 2 to the 3rd power, and 2 to the 3rd power is 8. It was supposed to be 8 all along, so we just said, yes, this is actually an answer. It is not extraneous. Last problem. I have an entire expression raised to the 1/2 power. I am asking myself, what exponent am I going to raise this expression to, so that this exponent times the one I want to raise it to will multiply together to give me 1. This is 1/2. This will be a 2. If I'm raising the left side to the 2 power, I'm going to raise the right side to the 2 power. 1/2 times 2 gives me an exponent of 1, so they 1 each other out. So I have x plus 6 equaling x to the 2nd power. I'm going to make this problem equal 0. And now that it equals 0, I can solve by factoring. So I need to figure out a times c, somebody better add up to b. A times c is a -6, my b is a +1. 2 numbers to multiply to get -6, but add to give me a 1. Would have been a -3 and a +2. Nope, those add to give me a -1. Must be a 2 and a -3. These multiply together to give me -6. These add together, they're the same thing. That was a -2 and a +3. These multiply together to give me a -6. These add together to give me a +1. So the numbers I'm using are a -2 and a +3. Because a is not 1, I have to factor using the area model. Highest exponent goes in the top left, lowest exponent goes in the bottom right. These middle x's are going to be rewritten using the numbers you chose. You chose -2 and a +3. GCF across the top, it's an x. Now x times a -x will give me the -x². -x times 2 gives me a -2x. 2 times 3 will give me 6. 3 times x gives me 3x. So I have a -x plus 3, and I have an x plus 2. And now each expression is supposed to equal 0, and we're going to solve for our x. So our answer is x equals 3 and x equals -2. But your job is to also check, are these extraneous? So we have 2 solutions that we need to double check. So this is where solution 1 is going to get checked. And here is where solution 2 is going to get checked. The x's are the solutions. So over here, I'm going to test the solution 3. And over here, I'm going to test the solution -2. So testing the left problem, I have 9 to the 1/2 power, which is the same thing as the square root of 9. Square root of 9 is 3. It equaled 3 all along, so this is correct. Check the right side. This is 4 to the 1/2 power, supposed to equal -2. 4 to the 1/2 power is the same thing as the square root of 4. The square root of 4 is 2. This was supposed to equal -2 all along. That is not true, which meant that -2 is an extraneous solution. So we only have one answer. X equals 3 is that one answer.